let's continue with the serialization and deserialization. What if at times you have a transient variable, but you actually want to go ahead and serialize it? There are situations wherein we have, say, there are WhatsApp messages that are encrypted, there are emails that are encrypted. What if I want to do a customized encryption of my information that goes into a file that only I know about, and when possible, decrypt it? Okay, that's when I would think of something like customized serialization and deserialization. How do I go about it? There is a class called student new which implements serializable, and this is what we have already seen. There is an instance variable called roll number, there is an instance variable called name, there is another instance variable called Aadhaar number which is of type string. Okay, so here there are two constructor methods. One is a zero constructor, one is a parameterized constructor, and here we have display. Imagine I want to write this information, that is Aadhaar number, onto a file, but I don't want to write it directly. Why? Because then if I write it directly, then it is readable by everyone who has access to the file. What I would do is I will write it, but with my own encryption into it. For doing that, if I scroll down, you would notice that there are two methods. These two methods are from the object output stream. We have used those methods before. We have used the write object to write something, or we have used the read object to read an object. What is happening here is I'm trying to override both the methods, and I'm trying to put in my own logic of encryption before I write, and removing that additional encryption what I have, decrypting and read the method. For that, I will have to call this default write object inside this write object method. I have this default write object there. I will write onto the file. When I write, what happens? The non-transient variables will get copied onto the file. Then what happens to the transient variable then? Can you see this encryption, what's happening here? The regular Aadhaar number which is available, I am adding a text 123 before it. And then now when I write os.write object, the encrypted Aadhaar number goes and gets saved in the file. Similarly, when I read also, this default read object is here. The non-transient variables will be read inside the overread read object method. Then this Aadhaar number I am copying onto it, reading the Aadhaar number that is encrypted, decrypting it, and then writing it back to the object's Aadhaar number. This is a method. So here what we are trying to do is, so this is what we would do here. We would override these two methods of write object and read object so that I can encrypt and decrypt the values that are there within the transient variables. Now going to the next topic. What happens when serialization of inherited classes takes place? Now in that there are two scenarios. In the first scenario, we are talking about a parent class that is serialized and a child class that is not serialized. What would happen in this instance? So here is my college student class, which is the child class, and here is the student class, which is the parent class. Okay, and this parent class is implementing this serializable interface. So here the child class, I've written here college student extends the student. That means college student is the inherited class. And here I'm using the word super, R and N, because those two values are there in the parent class. Same thing with super dot display, because that part of the parent class, this method I want to be called. Now, what's happening in the main program? In the main program, I'm creating an object S1 of type college student, with 3 values. I have 10 for roll number, Anu for name, and BCA for the course. BCA is this. Okay, I want BCA to be part of this variable. Okay, and here I'm saying system.out.println serializing and then s1.display. Now, the same method we follow to serialize. Just because there is inheritance there, we are not doing anything extra or anything special. The normal steps for serializing, we have the file output stream, which is connected to the object output stream, and then we have object output stream.write object, and I'm writing S1 onto it. And to deserialize, I have the reverse process, which is I have the file input stream with FIS, connecting that to the object input stream, and then reading using read object onto this object called S2 and going ahead and displaying. I will execute this file. See, both the serialization and deserialization has happened. What do we infer from this? We infer that if the child class need not implement serializable as is inherited from the parent class, because parent class has implemented the serializable interface. Now, what is the second scenario in this? The second scenario being these tables get reversed. The child class is implementing serializable. The parent class does not implement serializable. What happens then? For instance, I have a small example here with the class AB being the parent class, which is not implementing the serializable interface. The child class XY, which of course I'm writing here extends because this is the child class. It extends from inheritance from the class AB, and that is implementing serializable. Going back to Java, here are the classes I was talking about. There is the parent class AB, which has a variable I. Okay, and there's a small display method. There is a class called XY, which is the child class. I have a variable M here, instance variable, with 20 as the value. Now coming to the main program, I'm creating an object here called object1. And to object1, I'm changing both the values. I'm changing the value of I and changing the value of M. I being the instance variable of the parent class and M being the instance variable of the child class. See here, I had value 10 and M had value 20, which both I am changing. After I changed it, I am trying to serialize now. That means basically speaking, 777 and 888 should get copied on to the inh_1.txt. Does it happen that way? And here, this is the reverse process. Okay, I have the file input stream, the object input stream, and I'm creating an object2, which is what value that I've read from the file inh_1. So when I execute this file, see this was the value 777, which I've given in the main code. But is that getting serialized? Is that value getting copied onto my text file? No, it is not. Why is it showing me 0? Because 0 is the default value the variable had. If you scroll up here, in the default constructor, you can see I equal to 0. That is what is copied onto the file. That means since here the parent class does not implement the serializable interface, okay, any value that is there other than the default value does not get copied onto the file. But on the other hand, M is a value that has come from the child class. Okay, that also was 20, I've made it 888, but that 888 value is getting copied. Why? Because the child class is implementing the serializable interface. What happens when the child class implements serializable interface and the parent class does not? What happens here is any instance variable of the parent class, only the default value gets copied onto the file. Any change in the value, anything done, no changes will be copied onto the file. Whereas any changes made to any variable within the child class will get copied onto the text file because it is implementing the serializable interface. So to sum up everything here about inheritance and serialization, if a superclass is serializable, then according to normal Java interface rules, all subclasses of that class automatically implement serializable implicitly. It happens. I don't have to do anything extra within the code. But on the other hand, if the parent is not serialized and the child class or classes are serialized, then the parent class variables will not persist. Persist is another name we say for storing of the state of an object, or the state of the parent will not persist in the file.